This is 2.5, 2.5a. This will probably take a couple videos, and we're just going to start right in on this. We have what are called compound inequalities. A compound inequality are more than one inequality in a problem. So for instance, if I had, this is example 1, if I had that, that's a compound inequality because there are two inequality signs. So what this is saying is x has to be a number that is less than or equal to -2 or greater than 3. We have two possibilities here. So when it asks you to graph this, we're graphing like this, putting 0 there, putting -2 here, and putting 3 over here. And when it asks us to graph, we graph this. X is less than or equal to -2, so I'm making the square, and it goes this way. And we're also graphing this. X is greater than, not equal to, so it's rounded, and we go this way. So what we're saying here is x can be either this number or this number. Not both, obviously, because if x is -4, obviously it can't be +4. So it's going to be one or the other, not both. So it gives you a choice of x being two different options here. A number less than -2 or greater than 3. And another way that you can write this using interval notation, it's a little hairy here, but remember this is going to -infinity, and this is +infinity. So we can write interval notation of this. Like that. And then we can write 3 +infinity. Okay, now the thing that's important here is there is a symbol that we put between here, and that is the union symbol. Whenever you have the word or, you use the union symbol. So very, very important to remember that as you're doing that. And we will continue on because not all the time will this be an or. Sometimes it'll be an and there's a different way of doing that. But let's stick with the ors right now, and then we will move into some other areas later. Okay, so example number 2. X is greater than or equal to -2, or x is greater than 3. All right, let me explain. Oops, let me make my parentheses better. Let me explain what these symbols here mean. This says the set of x such that, this is a vertical line, even though it looks kind of hokey here. It's a such that sign. Good to remember this. All right, so the set of x such that x is greater than or equal to -2 or x is greater than 3. So pretty much just says x can be greater than or equal to -2 or greater than 3. So let's look and see what that looks like if we were to graph it. So we've got 0, we've got -2, and we've got 3. So what this says, if we were to graph this, it's greater than or equal to -2. So because it's greater than or equal to, we will make our square bracket here, and we will show our arrow into +infinity right there because it's bigger than or equal to -2. In blue, it says x is greater than 3. So we're going to make our rounded one and make it bigger than 3. Okay, so that looks all nice. So because it says or. We use the union symbol, the U, and we graph their union, which means we graph all points on either graph. We graph all points on the red or the blue. And since all points on the red or the blue start here and go to the right, then we graph it as one long graph. We don't even have to put this on there. We just have a graph that starts at -2 with the square bracket and goes to the right into infinity. We can write it in interval notation by giving us a positive infinity there and a -2 there. Oops, I'm sorry. I wrote the interval notation with the wrong symbol here. So this is squared, meaning that it includes the -2. And finally, when we have one like x is greater than or equal to -2, or x is less than 3, in order to graph that, get our graph up here, and we're going to graph both of these. So there's 0, we've got -2, and we've got a 3. So let's go ahead and graph this. X is greater than or equal to -2. So we'll put our squared bracket there to include -2 and go to the right. Now we're going to graph x is less than 3. So x is less than 3 would be rounded. And if it's less than 3, it would be that way. So again, because of the or, it's going to include all points that are included in both of these. And in this case, it would be everything to the left, everything to the right. So therefore, our number line would be like this, and our graph would include all numbers in the history of forever. And our answer in interval notation, -infinity and positive infinity. All right, so now let's look at the and. X is less than 2. All right, so the difference between or and and. Or means that it needs to work for one inequality or the other. It does not have to work for both of them. And means that it has to work for both of them. If there's a number greater than -1 and a number less than, an x is less than 2, that has to be true for both statements. So, for example, we could not use -4 as one of our answers. Although it's less than 2, it is not greater than -1. So it has to be true for both of these. So here's what we're going to do here. We are going to graph each one again. So here's my graph. I'll put 0 here, -1 here, and 2 here. So x is greater than -1. So I'm going to put rounded and go greater than. And then in red, I'm going to do x is less than 2. Rounded, less than 2 into infinity. All right, so the answer ends up being where or what these two graphs have in common, where the red and blue are together. See, over here it's just blue, over here it's just red, but where they're red and blue together, that's what we're going to use. So we're going to, for the most part, just get rid of everything where the blue and red aren't together, and that ends up being our answer. 2 rounded, oops, wrong pen. 2 rounded, and everything in between there. If you were to write this in interval notation, it would look like that. This is as far left as we go. This is as far right as we go. And we put it that way. And this is called open interval. An open interval means that neither endpoint is included. Okay, so this endpoint and this endpoint are not included. If it was square, then it would not be an open interval, it'd be a closed interval if both of them were closed. But in this one, we're in a open interval. Okay, example number 5, we've got x is less than -1 and x is less than 2. So let's go ahead and graph that. We've got our 0, we've got our 2, and we've got our -1. X is less than -1. So open this way. And x is less than 2. Okay, again, because of the and, we look at where the red and the blue intersect. It's an intersection. Remember the other ones, when it was or, was a union. When it's and, it's an intersection. So the answer actually is that. My graph starting at -1 and going into infinity to the left. And if you were to write this in interval notation, you'd have -infinity to the left and -1, the furthest point to the right. And again, that is called an open interval because neither endpoint is included. Now, if you look at example 6, we have something that's a little bit weirder, more weird, is that a word? And x is greater than 2. So let's graph it. 0, -1, 2. Okay, so let's graph red. X is less than -1. And then in blue, x is greater than 2. So looking at this, does the red and the blue intersect in anywhere? No. It does not intersect, which means your answer is the null set, the empty set. It does not exist. There is not a number that makes this true and this true. There are numbers that make this true or this true, but not and. So when that's the case, you get the null set. So when we're dealing with the ands, one of the things that is important here is if I look at x is greater than -1 and x is less than 2, I can write this in a more streamlined manner and I can put some things together. So I can write -1 is less than x. Notice -1 is less than x, or x is greater than -1. I just changed the order around and turned the sign with it. And x is less than 2. So I wrote it without the word and I put the x in the middle. So if the x is less than 2 and it's greater than -1, I can write it this way. So that is more of a shortcut way of doing it. So I'm going to look at example 7, because 7, they just kind of jumped into it without really explaining what was happening here. So 2x minus 5. And notice the x is in between the two inequalities. That's what we want to see happen. So we're going to do something pretty weird here, but we're going to try to get x by itself. Well, when we try to get x by itself here, we have to add 5 and then divide by 2. So what do we do? How do we add 5? What we do is we add 5. What we do here to get rid of numbers, we do over here and over here. So let me show you. We add 5 here, add 5 here, add 5 here. So on all three sides of the inequality sign, we add 5. So here we get 2 is less than 2x, because those cancel, less than or equal to 8. Now we divide by 2, divide by 2, divide by 2, And we get 1 is less than or equal to x, which is less than or equal to 4. So now we're back to something that makes sense. And then we can graph this. And this is the nice thing about this type of problem. When we put them all together in 1, 2, 3 terms with 2 inequalities instead of writing the word and, it makes our graphing a whole lot easier. All we do is we look what's over here, look at what's over here. Whoops. Let me move our 0. Move our 0 over here. Move our 4 here. Okay, because everything's to the right of the 0 because it's positive. And it gives me a less than or equal to sign. So 1 is less than or equal to x, so that's going to be square. My 4 is greater than or equal to, so it's also going to be squared. And then the x is in between these. So that ends up being our graph. It makes it real easy because all we have to do is look at what's on the left and the right of the x, and this determines whether it's rounded or squared, and then that's it. We're done. All right, so let's look at example 8, which is a compound inequality using the word or. So we're going to go back to the or thing. The ors are kind of a pain, but we will keep working with those. I'm going to use an x instead of a t. Or 3x plus 7 is greater than or equal to 4. All right, so what we're going to do, this or keeps us from meshing them together. So we solve this separately. Solve that, and then we solve that. So let's go ahead and do this. Subtract 7 from both sides. So we have 3x is less than or equal to negative 11. X is less than or equal to negative 11 over 3. Or 3x minus 7 from both sides is greater than or equal to negative 3. Divide by 3, divide by 3. We're dividing by a positive, so the signs don't change, and we get negative 1. So we get this, or we get that. So when we graph these, it goes back to the same way that we did before. If we're going to graph this, okay, negative 11 thirds, which is 3 2/3. X is less than or equal to, so we're going to make our cool little bracket there, and it's going to go this way. And then it says, or x is greater than negative 1. So I'll put a negative 1 there, and it's greater than or equal to, so it's also going to have a bracket. But since it's greater, it's going to go that way. And we're done. So if they ask you to graph it, that's what it's going to look like. If you wanted to show this in interval notation, we show this graph, negative infinity, and negative 11 thirds with the box, union, box, negative 1, positive infinity. That's what that would look like in interval notation. Okay, so there's two other examples, example 9 and 10, that I'd like you to look over. I don't think you need me to actually do them. They explain them pretty well there. And we'll call that good then for 2.5.